All right, guys, day two. So remember, you need to have knocked out day one for my virtual students before we ever touch on day two. Otherwise, you're going to be very confused. Day one first. That is a must. And if you have not done day one and are having problems with the Ed Puzzle, I've attached a video on Google Classroom right beside the Ed Puzzle that is the same exact video, just without the questions. If the Ed Puzzle can work, though, and it's a school issue, we're having a tough time connecting to YouTube, then at home you may not have the same issue, but you still have that video to help you out. But today, we're going to be talking about relations and functions. Now, we talked about relations. We talked about that on day one. So if you're confused, maybe we'll look back at day one, which we'll discuss the vocab here in a second. But as far as day two is concerned, we're really going to get into what's called functions. And hopefully you have heard about functions before, but if not, I want you to know that they are relations, but that not every relation is a function. So some relations are functions, but every function is a relation. Kind of like the whole every square is a rectangle, but rectangles aren't squares deal. All right. So we see domain and range are making a comeback. That word functions, we're dealing with graphs. That's going to be more on part two. This third standard is going to be more part two, whereas these first two are by far going to be part one for sure. Part one and part two there. Now, quick reminder, a relation is a pairing of two numbers into one set. And the example we used on day one was ordered pairs, aka coordinates, x and y. These two numbers are known as, again, little reminder, domain, which is the first number in the set. We call that x, or the input, and range, which is the second number. Great highlighting job there, aka y, aka the output. Now here's the key. A function is a relation, so a function is a relation, in which every element of the domain is paired with exactly one element of the range. You could also say that a function is a relation in which no two distinct ordered pairs have the same first coordinate. So if this definition, every element of the domain goes to just one range, or every ordered pair has the same coordinate, if that doesn't make sense, let me simplify it even more. X cannot repeat. It is as simple as that. X cannot repeat. If X repeats, you don't have a function. If your domain repeats, you do not have a function. So, here's how we're going to do this. Let's do number one together, and we'll do number two together, and then I'm going to let you guys try number three. First, we want to determine, is the relation a function? And then for those that are not, we need to identify two ordered pairs that make it so they're not. So which two coordinates have the same x? Then additionally, regardless of whether it's a relation or a function, we're going to identify the domain and range. So two things here. Tell whether it's a function. If it is, then label the domain and range. And if it's not, tell why it's not, and then label the domain and range. So let's start with number one. Here's our relation R. So relations have names, usually. This is relation R. So let's check the x's. We've got -2, 2, -2. We got a repeating x. This is not a function because of -2, 5 and -2, 3. So this is not a function. It's still a relation, but it's not a function. Now, even if something's not a function, it still has a domain and range. So we'll label that domain and range. The domain are going to be all of our x values. That'd be -2, 2. -2 repeats again, so we don't have to write that down. And then 3. And then range, we've got the y's, 5, 4, 3, and -9. Okay? Now this next one, I'm going to work with you to see if it's a function, but then I'm going to let you guys try the domain and range. So this one, is it a function? -1, 1, 2, and 3. None of the x's repeat. Hey, that's a function. And I know some of you guys are saying, wait a minute, but the y's repeat, 1 and 1. Well, we don't care if the y's repeat. It's about the domains, the x's. And we'll discuss why that is here on the next page on part 2. But now I'm going to let you guys give me the domain and the range. You can go right ahead. See if you can do both of those. All right, so here's our domain. Here's our range. We can see that the range repeats. 1 shows up twice. So that's why our range has 1 fewer return than the domain. But we don't care that the range repeats, as long as the domain doesn't. This is a function. So I'm going to let you guys see if you can run the whole thing. That's why I tried to give you some room down here. Let me know if it's a function. And if it isn't, let me know why. Point out the 2 points that make it not so, the 2 coordinates. And whether it is or isn't, you're going to need to give me the domain and the range as well. So go ahead, guys, pause the video. See what you can do on number 3. Okay, so this one, number 3. Ooh, we have 2 points where they have the same x. This is not a function. We have repeating x's. These 2 points will be stacked on top, sort of each other. They'll be right above each other. And we're going to talk about why that fails something very important on part 2. So not a function. The domain is going to be 6, 3, -1. We don't have to write that second 6. And the range is -1, 2, 4, and 5. So we're going to end part 1 today, guys, by bringing it back to mapping diagrams and determining based off them whether the given relation is a function or not. That's going to be our mission here. So consider the following mapping diagram. Determine if it is or is not a function. And remember, a function is a relation in which every element of the domain is paired with just one range. So every x only matches to one y. Let's see how this goes. So we've got -1 only goes to -4. That's good. 0 only goes to -2. That's good. 5 goes to 2. 10 goes to -2. And oh, no, 10 goes to something else. 10 goes to 4, good buddy. So we have 10 going to 2 different ranges. If these were coordinates, it would be 10, -2, and 10, 4. So this is not, I have to go NF. That means not a function. So I'm going to let you guys to end part 1. Try numbers 2 and 3. See if this is a function or if this is a function. If it is, you can just put an F or write function, and if it's not, you can put an NF for not function. Go ahead and pause and try. Okay, number 2 is a function. Every x goes only to one y. Number 3, -9 goes to -6, 3 goes to -6, 5 goes to 4, 11 goes to 8, and oh no, 11 also goes to 4. We've got 11 showing up in 2 different points. That is not a function. And so, guys, that'll be the end of part 1 of day 2. Look for any assignments that maybe you've missed, and I'll be talking to you soon. Go Jumpers.